wants to get these beautiful pictures of the day coming in with the stories related to them.
The main NASA website does have the explanation, which is around 150 words, sometimes longer. That's hyperlinked into the web. So we have a lot of hyperlinks sometimes. You can have these 15 hyperlinks in those 150 words. Sometimes fewer, sometimes even more. The idea is to explain on a wide variety of levels. So I've given talks about APOD to elementary schools.
Nice.
And I've had discussions about different APODs with professional colleagues. So we try to do a dynamic range, but we don't always succeed, but that's one of our goals. So the image can be appreciated at some level. The beginning of the explanation usually can be appreciated at some level, and as you go into it, it might go down to deeper levels. And if you follow some of the links, they go to actual research papers sometimes.
Oh, nice.
So if you thought that something was really interesting and you're a professional in this area, you can click the link and see what research paper we're talking about.
I bet this really enhanced the readership of lots and lots of papers by just making it easy to find and not have to look it up,
Mm-hmm.
Well, good. So some links are posted out there, and
right. The last one I posted is just to APOD itself, and the one before that is to the About APOD page, and that is where you can find links to all of the translated sites, links to the official APOD mirrors on Facebook, Twitter, Reddit, Instagram, etc. You can get the email from there. There's a link to the person to email if you want APOD to show up in your email box every day.
Nice.
English is not your preferred language, maybe Spanish or French or German. You can
or maybe you want to learn Dutch,
right?
And
compare the
two. How did you know, Alice? I am actually, in fact, learning Dutch.
So I see a question, where is the M2 Observatory? It's in Atlantic Mine, about 4 miles from here. More here meaning the center of Michigan Tech. It's not all that active observatory right now. It's had some problems in the past, but you can email the current director, who is not me, from the M2 Observatory page. You can get from Googling M2 Observatory. We do have, though, a 25-inch student telescope, which is not really for 25-inch students. It's 25 inches the size of the mirror. And it's in Fisher Lobby and sometimes taken out, and you can see like rings of Saturn, from the just off, Fisher Hall lobby.
That's pretty cool. All right, I'm going to do my intros now. So I'm going to share screen and present my slides and introduce Alice. So share screen. There we go. Can you see my screen?
Yes.
All right. And there we go. All right, this is, so welcome everyone. I want to just formally welcome you. This is our last Husky Bytes of season 4. This is fall 2021, and my name is Janet Callahan. I am Dean of the College of Engineering at Michigan Technological University. And I would like to acknowledge the sponsorship of the Fraternity Brothers of Tau Kappa X Epsilon, aka known as the Teeks in town. And my good friend Jim Schluckbeyer, who my first alumni reunion, I believe it was, said hello to me, and we've been friends ever since. So thank you, Teeks. I wanted to show you the spring menu. So when we get back together in the new year, our first one will be the first Monday. Well, it'll be January 24th, and we're going to have a 10-week season. And I'm just going to introduce each topic very briefly. The first one's going to focus on Winter Carnival. And if many of you alumni know Winter Carnival is out there in the first part of February. So we're going to launch the season with Winter Carnival because it happens to be the 100th year anniversary of Winter Carnival. And so the university archivist, Lindsay Hiltonen, will be our lead speaker that day. And then we're going to do a little bit of topic on fermentation with breweries above and below the bridge, featuring alumni from Big Buck Brewery and alumni from our own KBC here in town. So that making it below and above the bridge. Then we're going to have Brad King back in, who is a mechanical engineering faculty member, talking about the nanosatellite ORIS, which they are going to be getting ready to be fitted for space. And then it's February 14th, which happens, of course, to be Valentine's Day. And we have Hoda Hatum, who's going to speak about her work on fluid flow in the carotid artery, and we're calling that Heart and Soul. This is followed by distinguished Professor Zhanping Yu, who does research on using recycled rubber as an ingredient for pavement. And that talk is called Where the Rubber Meets the Road. And that he's a faculty member in civil and environmental and geospatial engineering. And then we're going to have a really fun evening with Martha Sloan, who is a professor emerita from electrical and computer engineering. And I'm calling that Tech Tales. So I'm looking forward to that. We have spring break. We will not meet during spring break. And then we have 4 to close off the season, beginning with chemical engineering, Dr. Karen Helt, who is an expert on viruses. It'll then be followed with a set of students speaking about their recent experience in Glasgow, Scotland, where they were Michigan Tech Agents of Change. And that's led by Sarah Green, who is the chair of chemistry. Then we're going to this will be a deep dive into wind energy with Fernando Ponta.
18 hours.
And no, it's okay. It won't be that long, I promise. It won't be 18 hours, but he gets technical. And then we're going to end it with Tom Werner from Biology talking about his work on butterflies, moths, and fruit flies in the Keweenaw and beyond. So that's the spring lineup. We're going to be sending that out via email and all that sort of thing. This is still a little bit tentative, but I wanted to give you an idea of what was coming up next. Thank you to all the sponsors this fall. And this is probably isn't a complete list, but we tried to make it. And if we've missed anybody, please let us know. And if anyone's interested in sponsoring one of these, 100% of the proceeds go to students all across the university. And just send an email to engineering@mtu.edu if you would like to do that. And thank you again to the Gregorys for your matching gift. All right, see you next January. So that's about 2 months from now. And if you have questions during the talk, write them in the Q&A feature. That's the way to ask questions here. We'll be introducing my co-host Alice Allen, but before I do, I just want to make sure to wish everybody a happy Thanksgiving and to thank everyone for attending this season. And with that, it is my great pleasure to introduce Alice Allen, who I've just recently gotten to know. She's a faculty specialist in the Department of Astrophysics, I believe, at UMD College Park, Maryland. She has an educational background in, as she mentioned, medical lab sciences, and then she went on to work in IT at the Federal Reserve Board in Washington, D.C., where she was the IT expert and ran the software training for the Federal Reserve. So Alice became a fan of the astronomy picture of the day when it was launched in '95 by Professor Nemiroff, and they'll talk more about that in a moment. She retired from the Federal Reserve Board a few years ago and now works even harder as a volunteer. And one of the things she does is she handles all the editorial responsibilities of the Astrophysics Source Code Library. And in Robert's words, Alice's passion is in looking up. So with that, I'm going to turn it over to you, Alice.
So thank you so much, Janet. I'm very happy to be here. And I'm delighted to introduce tonight's special guest, Dr. Robert Nemiroff, who started the Astrophysics Source Code Library and about 11 years ago talked to me about it. And I just I took the keys and the steering wheel and drove off with it. Is how I feel sometimes. But Robert is a university professor honoree and professor of physics at MTU, and his research is concentrated on microlensing, gamma ray bursts, and the use of relativistic illumination fronts to orient astronomical nebula. So trying to figure out information about these nebula. He's the co-founder and co-editor of NASA's very popular outreach and education website, Astronomy Picture of the Day, which is often referred to as APOD. And he and his colleague, Dr. Jerry Bennell, won the Klemke-Roberts Award in 2015 for this project, which has been online since 1995. Who even remembers what the web was like back in 1995? Robert is always finding ways to apply technology to do cool and interesting things. For example, back in 1994, some of you who were on the call early heard that he and Dr. Bennell, Jerry Bennell, were the first to freely publish the first 10 million plus digits of the square root of 2 and of the irrational number e. And he still gets occasional emails about this project because the information is still available online all these years later. And Google, I believe, has actually published a book on this. So you can download these 1 million or 2 million or 5 million or more digits. And I can supply the link for that once I'm done talking. So he was also the first to build an online fisheye night sky monitor called CanCams. And he was involved in deploying later models of this to most major astronomical observatories, which was really cool. So you could monitor the night sky all the time locally. He had an early interest in using smartphones as science sensors too. And as I've already mentioned, he's the founder of the Astrophysics Source Code Library, which started in 1999. And he's currently writing a book about things that can go faster than light. Yes, some things can go faster than light. We can't though, but he always has interesting projects going on, and he's very good at getting people with an interest in astronomy, but who didn't major in it, working in astronomy. There's this whole vast array of volunteers who do work around his projects because they're such cool projects to do. So now, without further ado, let me turn the microphone over to Robert.
Well, thank you. I hope I can live up to that very nice introduction. But first, I want to share my window that has my PowerPoint presentation because you're more interested in seeing the slides than me. So
share with sound. Remember to share with sound.
Oh, yes. Thank you. There we go. So you should be seeing a thing that says NASA's best space images. You may have received a mild shock. I'm sorry. No, there's no shock. Okay, so this is about some NASA's best space images. We're going to be, I'm going to be summarizing basically the ones from 2021, but I'm going to start a little bit earlier because there's some really cool ones that have come out in the past 2 years. So I am Robert Nemiroff, and I'm the PI of APOD, the Astronomy Picture of the Day. That's what APOD stands for. And I'm professor in the Department of Physics, Michigan Tech. So let's look at APOD for a bit. It's not hard to find. It's apod.nasa.gov. It started in 1995. It is currently, and has been for a while, NASA's top science website. It currently does about 1 million page views a day. Back when we checked this, the log files, we would find that every university, every major university, we could find access to APOD every day. So APOD is translated by volunteers into about 20 languages, and it's available on most web and social media platforms. Okay, so with that, we will go to our first image. Now, these images today I'm going to show you are a bit engineering oriented because I know who the major audience is. And many times I show some of the more spectacular astronomy type photos. But we're going to have a couple of those, but we're going to mostly focus on cool NASA missions that involve engineering in some sense. So this rock here, about 500 kilometers across, was not engineered. It's called asteroid Bennu. But what happens is there's a spacecraft out there called OSIRIS-REx. And this was launched, the OSIRIS-REx was launched a few years ago. This image, I'm not just making up. I didn't just do this in Photoshop. It's a real image from OSIRIS-REx, but all of the images and videos I will show you today, and this is actually a video, it doesn't seem like it now, maybe around you can see the arrow. You can see this as many times as you want by going to apod.nasa.gov apod.nasa.gov and looking for all the images are online, all the videos are online in several ways, one of which is chronologically. You go to December 23rd, 2019, and this is a 23-second video. So I will try to put the credits up here. And so here is Bennu. OSIRIS-REx went around. You should see this, rotating on your screen, and there are going to be 4 sites coming up that they wanted to land or have OSIRIS-REx take a surface sample from. One of which is Nightingale, the other is Osprey, one is Kingfisher, and one is Sandpiper. These are relatively flat parts of Bennu. The idea is to take a soil sample and return it to Earth, which is pretty ambitious. So after investigating these in some detail, Nightingale was chosen. Now we're going to come back to this. Okay. So the next thing I want to talk about is the Parker Solar Probe. This is a NASA mission out near the orbit of Mercury. So we live in a golden age where NASA and other spacefaring nations have put satellites all around our solar system. And we're going to show you some of the cool things that have come in over the past year or so from around the solar system. So this is the Parker Solar Probe, sounds of the solar wind. So what you're seeing here is a picture of the solar system, although it doesn't look that good. It's going to get better. Trust me on this. You're looking sideways. The sun is off to the left here. It's so bright, there's a sun shield. So you can't have the sun right in the field of view, it's too bright. So the sun shield is protecting the spacecraft from heat and the cameras from light. You're looking off to the side. So what happens is the sun is not just static. It gives us the light that we need. If the sun was to go away, we would have big troubles. But the sun also throws off a solar wind of particles. And so the Parker Solar Probe is partly there to monitor what the solar wind does. Now the solar wind sound actually travels very faintly in the solar system because there's very little stuff for it to go through. But you can sonify it by having the particles that come off the sun and the solar wind, which are moving really fast, hit different things and measuring different fields. And you can then create sounds which you can listen to and then try to figure out what they mean, which is what is happening now with the Parker Solar Probe. So this is Earth from the Parker Solar Probe, this dot there. I hopefully you can see the little hand I have there. So now you're hearing a second kind of sound. And you can see deeper. We found out that the solar system is a different place in near Mercury than it is out here at Earth. And here comes another planet. And here comes a third sound. This is Venus. Very bright. So if you can't hear the sounds, somebody chat me or something. Okay, I'm assuming you can. Good. All right. So Parker Solar Probe is still out there. It's still listening. It's still watching. And you can see the Earth routinely from the inner solar system looking out from the sun. Okay. So this iPod appeared again last year. It was just so cool. I decided to replay it now. So this is not a real image from any NASA telescope. This is an illustration. It's an illustration of a binary star system called SS433. In here is a black hole. And here is a relatively normal star, well, a little bit bigger than normal. But the black hole has such powerful gravity that it pulls off mass in this illustration, this illustrated video from the big star that circles around and creates an accretion disk around the black hole and shoots out massive or powerful jets that are going like 20% of the speed of light. So let's turn this on, and you can see in a time-lapse illustrated video what is happening in the SS433 system. So we can see the results of this by different satellites. So what you're seeing now is another animation. This isn't taken by a satellite. You can see the jets spiraling around as SS433's black hole spins and precesses, and the jet spins and precesses. And so this has been seen by the Hawk Observatory, which has major players right here at Michigan Tech, HAWC, that it's an observatory of high energy gamma rays that is situated in Mexico, but again has a major players here at Tech, and then also the Fermi, NASA's Fermi satellite can see parts of gamma rays coming from the area, which wasn't known before. This was put together by the DESI Science Communication Lab, not by me. Okay, so we showed you Bennu before, and we told you that we were going in for a sample. So here is the video of going in for a sample. This was done just last year. So many astronomy books, many textbooks tell you things of what happened a few years ago. But one cool thing about APOD is we're pretty up to date. So we can show you what's happening recently. So all of this that I'm showing you, almost all of it's happened recently. So here we go. You're now the OSIRIS-REx spacecraft, and below, it's a little bit choppy right now. Bennu is rotating beneath you. And it's got all kinds of boulders on it. And now it's going to start looking for the Kingfisher site, and it's going to match speeds with it. It's a relatively smooth site, so it can punch it without hitting a boulder and getting knocked off on its side. So here it is. So now we're going in. You're going in. Now you're going to see the shadow of the arm that's going to punch it. And when it punches it to kick up some the debris that it will then catch. There it goes. Bang. Now it has a little capture thing that it captured some of this stuff. So it did, and it sent it back to Earth to analyze. Bennu comes near the Earth. It's in the near Earth orbit. So we want to know the history. What's the surface of this like? Are there any rare minerals there? Because there's actually entrepreneurs who are interested in mining these things for rare minerals. We want to know if there's organic materials on there that help seed Earth. So we're going to find out in about 2023, I think, when the return mission lands. Okay, it's a big couple years for gravitational radiation. So we see light, we see electromagnetic radiation. And so when we look up in the night sky, we see, well, the daytime sky, you see one major thing besides clouds, it's the sun. It's the brightest star, so it's so close, it's so bright. But then once the sun goes down, you can see nearby stars that are usually within 100 light years in our part of the Milky Way. You can see planets. But just starting 5 years ago or so, new observatories on the surface of the Earth started being able to see a different kind of radiation called gravitational radiation. And so this is summarizing what the sky looks like in 2020. There was maybe 50 gravitational wave sources found out there. And this is solar masses on the y-axis. So these are really massive black holes that spiral in together. When they spiral in together, when they collide, they send out a huge burst of gravitational radiation. And once, at least, there was also a light that corresponded with it. And that was a really big thing, because then we could see that gravitational waves move at the same speed as light waves, and we could get models as to what the surroundings are like. So all the big blue ones are big, massive black holes. So when you look in gravitational radiation, you don't see nearby stuff. You don't see the sun, you don't see the moon, you don't see planets. You see faraway black holes that are across the universe. You also see some neutron stars down here in orange. And then you see these white things that are sort of between neutron stars and black holes, and we're not really sure what there is. So one of the things I like to do when I give a talk, I like not to say that science is a platform where you just declare the answers. Science is a frontier where you try to find more answers. So we don't really know what these white things are, and we don't completely understand why the blue things are distributed in mass the way they are. So we're learning all the time. Science is a frontier. Okay, so there's total eclipses. This is a total solar eclipse as viewed from the GOES-16 satellite last year, a little less than a year ago, 2020 December. So this is Earth looking, this is GOES looking at Earth. So you can see North America, you can see South America, and there was a total solar eclipse on December 14th. So what's going to happen, this is a video, and we're going to see, this is the nighttime. You're going to see daytime sweep across Earth, and then you're going to see a dark spot sweep the other way. That dark spot is the shadow of the moon. And when you see a total solar eclipse, you are momentarily in the shadow of the moon. So ready? Put your seatbelts on. Here we go. This is time lapse. Becoming daytime. See the clouds move. There it goes. That was a total eclipse, total solar eclipse looking back. That was so much fun. We're going to run that again. All right, today. shadow of the moon. So when you're on the Earth, that takes a couple of minutes to pass by. We had a big total solar eclipse pass through the United States back a few years ago, and in 2024, there's going to be another one that you can travel a little bit to the southeast and be in the path of that dark circle. And I advise it. It's a lot of fun.
I saw one. We were out in the boonies in Idaho.
Oh, cool. So you saw it firsthand.
We climbed up as close as we could get. It was pretty cool.
Mm-hmm. Cool. Okay, so this is the night sky. So the night sky has famous constellations, but the night sky has always had constellation. Almost every society that's seen the night sky has made up folklore and stories of the night sky. So we think of this as the constellation of Orion right here. Here's the belt of Orion, many people know. We think of this as the Pleiades star cluster. But Brazilian civilizations that lived for a long time, they didn't think of it that way. They thought of it as an old man. And they have a story. So this is the old man's head, and this is the old man's arms, and this is his leg, and this is his feather in his cap. And so this is the star Betelgeuse. But the old man lost part of his leg. His wife was angry with him. There's a long story there. And so this it's pre-Brazilian civilization has this great story. And so part of astronomy is actually folklore, trying to find out what these stories are and retell them. So this is a modern day Brazilian acting like the Brazilians back in the time when this was known as the constellation, the night sky. So we're happy to run this. Okay, this is one of the oldest, possibly the oldest rock known on Earth. Where was it found? Was it found in Greenland? No, it was found on the moon. It was found on the moon during Apollo 14 in the 1970s. This is also a video, I'll warn you. So this rock could fit on a desk. It's a little, it could fit on a desk. So this rock is a conglomerate of lots of stuff. So part of this was found to be, here I'll run the video while I'm telling the story. So it was x-rayed, and you're going to see slices of the rock as it goes from one side to the other. Part of this rock was found to have a make of very similar to things on Earth, but they were able to date it with radioactive dating, and they were able to say that, wait, this thing is like older within Earth than any rock on Earth. So it has elements of Earth, very similar to Earth, unlike the rest of the rock and unlike other rocks. But so even today, this was run earlier this year. This analysis has been ongoing for the past couple of years on moon rocks that were picked up during the Apollo era. We're being able to X-ray rocks and analyze them and find out new things about old moon rocks, really old moon rocks that we didn't know before. So this was a really old one. There's a whole lab at NASA, the Astromaterials Lab, that specializes in this. Okay. So let's go to the next one. So we live in an era of space exploration. So you might recognize these. This one's the easiest one to recognize. It's the moon. It's a full moon. I joke sometimes, with my wife that every time they show a moon on TV or the movies, it's always a full moon. So it's not always a full moon. It's only a full moon, maybe a day, a couple of days, then a month. But anyway, this was a full moon because we get most of our images taken on a full moon. And these are two SpaceX spacecraft. Was it SP9 and SP10? So these are, NASA is moving to a phase where it's funding other organizations to do a lot of the space flight. So NASA is still developing rockets, but it's funding SpaceX and Boeing and Amazon, Blue Origins and others to create spacecraft. So here we see two of them. One of them, these two were able to land back on their landing pads. This one had a bit of a problem. I think this one didn't. And things like this can, we have actually corporations that are going to visit the space station and will soon be going to visit the moon and possibly Mars in just a year or two, a couple of years. Okay, in this past year, we landed another rover on Mars, the Perseverance rover. And landing on Mars is hard. It's hard because you can use parachutes, but the parachutes won't slow you down enough. If you just use parachutes, you'd slam to the surface too hard. And if you use rockets, you'd have to have a lot of rocket fuel. So you have to have the best way. There's been a couple different ways, but one of the best ways is to come down first to parachutes and then go to rockets and then go to something called a sky crane where you're just lowered by tethers. So here it is. It's called the 7 minutes of terror because humans on the ground here at JPL couldn't really intervene very much. They could see the feed coming back, which has been condensed all here for us to see in this video. But you just have to watch and hope that everybody did their jobs. And different groups have different jobs. So here we go, landing on Mars.
We're starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Indicate chute deploy.
The navigation has confirmed that the parachute has deployed and we are seeing significant deceleration.
So people will clap at different stages because they're realizing that their third group has been successful. The group that did the parachute deployment is successful. Also, everybody's happy that it survived that stage because it's dangerous landing on any planet, particularly, well, Earth, of course, Mars also. A lot of
we are starting the straighten up and fly right maneuver at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
So
Perseverance has now slowed to subsonic speeds and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
You have to lose all of that velocity before you land. You have to land with just about zero velocity. So it's a battle to lose that velocity. Not hearing the sound anymore. Sorry, let's see. All right, I can talk it down. For some reason, the sound went away.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars.
All right, it's radar lock on the ground.
Continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
It's not slowing down much.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Here's where to land.
TBA is nominal.
Just figured it out.
We have priming of the landing engines.
It's going to use rockets now.
Back shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about 1 kilometer off the surface of Mars.
Here in Safety Bravo.
Kilometer up.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars.
Rockets. Found the place where it wants to
We
be.
have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver.
Sky crane, dropping it on tethers.
Sky crane maneuver has started. About 20 meters off the surface.
20 meters off the surface.
We're getting signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
So they did it. And now Perseverance is, I'll have a picture of it later, is on Mars, rolling around, exploring Mars, trying to find clues whether there was past life on Mars. So where is this? This is not Mars. This is Venus. The US has never landed on Venus. This is the Soviet Union. Back in 82 or 84, Venera 14. So this thing lasted for maybe an hour. And you can see the surface of Venus is really different from the surface of Mars. So the US is now a mission that's going to actually land on Venus. It's a lot hotter and it's a lot more dense on Venus, but it just looks like a completely different landscape. The reason I'm showing this is because a lot of the images that came back from Venus were highly distorted. But with modern technology and citizen scientists, they can download these images and patch them into what it would look like to actually stand there on Venera 14 and look out onto the surface. So even though a lot of these images came back, only recently have they been put in a position where you can see what a human would see if you just stood there instead of the unusually distorted images that were taken by Venera 14. So this is what it looks like with modern technology showing how it works. Venus is one strange place. Venus is also thought to have active volcanoes. That was discovered recently.
It's quite flat.
Yeah, it's part of it. Yes, it also has big volcanoes, but that part is really flat. And the rocks are flat too. Okay, here we have a rocket launch, a scene from the space station. This one has music to it too. So the space station needs to be resupplied, part of what SpaceX and NASA and Russia does. So Russia, this one is Russia launching from Kazakhstan. And so I'm going to just play this. I'll talk over it. You'll see the rocket blast off there. Head up, the whole thing. It's the atmosphere of the Earth. Close up. Ocean. International Space. Up there, you can't really hear the the lower stages flying back. Because it is to be a cloud. Okay.
Robert, we couldn't hear you over the music.
Okay, I was just describing the video. Sorry, yes, people couldn't hear over the lights. I'm sorry. So I'll try not to do that. I'll try not to talk over the music. But let's press on a bit. So black holes we saw before. Now, one of the ways that black holes intersect with stars is by shredding them as the stars go too close to it. So you see that in several ways. It is thought that we've seen a neutrino from a black hole star shredding event, but you can also see optical light. So here is again, this is not a picture from a space telescope. This is an animation that depicts what goes on when we do see optical light and gamma ray light and even a neutrino from this situation. And it's cool. Okay, so here you see the black hole on the right. The black hole has a gravitational lens feature around it. It was made famous by the movie Interstellar. And you're in the accretion disk looking at the black hole now. Soon we're going to look, I think, along the jet. I think they're trying to depict the neutrino coming out. So seeing as all the things we do in astronomy and astrophysics, it's kind of fun to see how people try to, as we understand better what's going on in the universe, mimicking it on the computer helps us to understand it better. So that was one case. Here's another case of the first stars. The first stars in the universe are a mystery. Our sun is a third generation star. It's made from stars that exploded and then reformed in other stars and exploded again and then formed our sun. A big question is, what were the first stars in the universe? So with the soon to be launched, very soon, hopefully, the James Webb Space Telescope, we're going to be able to see back to the era where we will get more information on the first stars than we've ever seen before. So this is, again, an illustrated video of the first stars forming. So this will pick up the action 134 million years after the Big Bang. It'll be kind of dark at first, but this little circle is going to show you one of the areas up close a little better. So as stuff comes together, it starts to glow. And these things are essentially supernova and massive stars. This thing actually shows you a galaxy that's forming there. And you can see the gas becoming gravitationally attracted and condensing into filaments as the universe becomes old enough to create the first stars. And so you can see the first stars in the orange things, and sometimes they blow up in supernovae. And this was the Sphinx simulations. Okay, moving on, trying to get through everything. Okay, here is a picture from the surface of Mars taken by Perseverance, which we saw land just a few minutes ago. So Perseverance carried with it something that has never been done before, never been seen before, never occurred on another planet before or moon. It's this thing right here, it's Ingenuity. So Perseverance is about the size of a car, rolls around Mars. You can see how Mars is different from Venus. But it put down this thing, it put down Ingenuity. Now, Ingenuity is about the size of a toaster with legs, longer legs than your toaster has, probably. But Ingenuity also has, you can see the solar panels up top. Ingenuity can do something that nothing else has ever done on Mars. It can fly. So Ingenuity is a helicopter. And after Percy, since it's called Percy and Ginny, after Percy backed away for the first time, Ginny spun around and lifted off the surface and has now done that several times, I think 9 or 10 times now. And it gets a view of the surroundings and helps Percy know where to go to investigate what to use its sophisticated equipment on. So Ginny herself doesn't really have much sophisticated equipment, but it can see where the cool areas are and can help future rovers, because it's a demonstration, and help Perseverance in particular know where to go. And this all happened this year.
Wow.
Okay, this is done on the space station. This is fire in space. So when we see fire here on Earth, you usually have this typical, I don't know, it looks like fire. You know, the top is blue and the bottom is more puffy and orange. But in space, in the microgravity of the space station, it doesn't look like that. It looks like a sphere. So this is the blue sphere on the outside here. So the orange things are the things that are actually glowing. They're glowing so hot, they glow orange. But when an oxygen atom, so fire is the rapid acquisition of oxygen. So on Earth, when it warms up, it goes up. But on the space station, there's no up like that. So when an oxygen molecule becomes close enough to have an exothermic reaction, it glows blue, and then everything in here heats up. So this is what fire looks like. And they don't create fires on the space station on purpose. Well, they do, but they need to know how to put them out. So one of the ideas is to study how fire happens on space and also how to put it out. You know, don't spray it with oxygen. Okay, so our sun is coming off a solar minimum that was unusually low. So our sun has a magnetic field that keeps changing every 22 years, sort of 11 years, and then it reverses and it's sort of 22. So we've come off of like months at a time where there was no sunspots. And the sunspots are places where the suns are just a little bit cooler because the magnetic field is pushing down on the solar surface and keeping really hot stuff from going in there. So this is a picture from the Earth of several sunspots. There's at least 4 here, sunspot groups. These are active regions. These also correlate sometimes. the active regions with aurora here on Earth. And I know there's many places on the web where you can go to find out when there's aurora. And I know there's a new group. There's actually a new astronomy group club at Michigan Tech. And one of the things they do is they exchange communications about when there's aurora up here. So you might want to get on that and see that. But here we can see a very picturesque shot of what seems to be a huge sphere on a hill, but actually the sphere is the sun and it's well behind the hill, and it's showing a lot of sunspots because we're coming out of solar minimum and we're going to show a lot more, the sun's going to show a lot more action. Okay, so this is the second to last thing, I think. This is Juno. So we have a spacecraft out at Jupiter called Juno, and it orbits Jupiter in looping ellipses that it goes near Jupiter every other month or so. One of these loops, though, they were able to engineer to go right past the largest moon in the solar system called Ganymede. Ganymede's a little bit bigger than our moon, and it has unusual patches on it. It has plate tectonics on it of some sort, and quite possibly it has oceans that might contain life underneath its frozen surface. So here we go. Let me say, a lot of this is put together by a lot of still pictures taken by Juno and put together by amateur digital artists that downloaded the images and put it together in a video so it looks relatively smooth. But it's actually relatively choppy, and they've interpolated between the different frames. They've also skipped a few frames. There's the sun. This is Ganymede. These are real pictures. Not all the motion is real. You can see grooves, craters, unusual regions that are being studied. That's a really close view of Ganymede. Now, we're going to skip a bit. By Juno. Juno still does. It's done like 30-some times now. And tries to measure things about Jupiter, like does Jupiter have a solid surface? Have sort of a liquid interior. And what's Jupiter's magnetic field like? And it's really choppy. What are the clouds like? They're like hurricanes on Earth. This approach was on June 8th, 2021. Music by Van Jack. Who did not visit Jupiter? It's put together by citizen scientists. Okay, you see flashes. Those are lightning flashes, but they're not real lightning flashes. That was added for dramatic effect. Now, there are really lightning flashes on Jupiter. That's true. And they really do correspond to the bright regions that have a lot of water in them. But they just put them in there to make it look cool. Those aren't real. So you're seeing one of the poles of Jupiter. You can see the North Pole. Lots of well, Jupiter's atmosphere is really cool. That are very close to the planet. You see huge storms called white ovals. All right, to leave more time for questions, I'm going to go to the last one. This is my last slide. Here's my last slide. So recently, NASA's launched the Lucy mission. It's going out near Jupiter, but not to Jupiter. It's going to visit 8 asteroids that co-orbit with Jupiter, either just before or just after, called the Trojan asteroids. Because in those gravitational wells, unusual asteroids, unusual rocks, probably have been accumulating since the solar system's been around. And so we want to know what's out there, what's been accumulating there. So Lucy just launched, is going to, starting in a few years, is going to start visiting. It's going to zoom by the Earth a couple times, then it's going to go out near Jupiter and visit a lot of these asteroids. And we're going to learn a lot more about the area around Jupiter and the early solar system. So with that, oh yes, APOD had its 25th anniversary in June 2020, and I want to give a big thank you to Dean Callahan and the whole Husky Bytes group for having us here. So thank you very much.
You're welcome. Gosh, it was just so stunningly beautiful.
So
we have the best solar system.
Oh.
Honestly, we've got this solar system is just, the planets are so cool, the moons are so cool. Everything out there is just amazing. And we get to see it. I mean, we get to see it up close. It's amazing to me.
I agree. So folks, you can use the Q&A to ask questions. And I know Alice has already answered a few by typing in words. Was there anything you wanted to brief us on, Alice, that people asked questions about?
Well, I have a question. I've been dropping stuff into the Zoom chat, and I'm wondering if participants can see that, and if somebody could say so in the Q&A, that would be one way for them to let me know. And yes, I believe there are videos of the Mars helicopter in flight. I don't know if I just stole Robert's thunder there. That's one of the questions.
Yes, we have captured that on APOD, but it's also, NASA has a bunch of videos. It's flown a bunch of times. Yeah, so you can see those. Ingenuity. So after a few minutes, I'm going to describe a little bit of my research, but I'd like to take APOD questions or solar system or universe questions now, but I could talk about my research in a bit.
So if I give, oh yes, okay, thank you, Evelyn, for letting me know that you can see the chat, and I'll put all of Robert's links in there. Okay, great. Thank you, anonymous attendee, for letting us know that you can go to APOD through the chat. I assume by clicking on one of the links. I'll put all of the links to, well, I don't know if I can do that, actually. That's all you have to do. I'll put the names of all of the APODs that Robert showed in the chat, and then you can easily click the search on the APOD.
Robert, may we post the slides?
Yes.
Okay, we will post the slides on mtu.edu/huskybytes. And that will have all the links, and I think that'll be the easiest way to see it. So the same place people go to watch the recording, there'll be another link with the slides. And thank you. And there's so many compliments out here. Warren says it was fabulous. Thank you. It was an amazing presentation.
Thank you. I see a question from Dave Chenard, who I know. I think it's the same Dave Chenard I know, who's a famous professor at Michigan Tech. And actually, we're two of the group that play noon basketball, although we're kind of on hiatus because of the COVID situation. But so I just had his question and I lost it.
How do you gather all of the universe of images and decide which to post on APOD?
Okay, good question. So we're sent a lot of images. So we reject about 20 images for every one we're able to post. But we also keep our eye out on social media, and we also we get all the emails from NASA and from the European Space Agency and from the Chinese Space Agency. And we're constantly looking for good images, but we're fortunate enough that we have many images that are sent to us. And then we just try to pick out the ones that are most representative of what's going on in research and what's going on the frontier and what's the most interesting, and maybe which ones have gone viral, and then explain those. Okay.
And just a shout out from the person who organized the TEEKs to donate money for scholarships. She says this is an interesting program. Average people don't get to see this type of photography and videos. Only Huskies, no.
There's another question on how you gather the information for each image caption.
Okay, well, being a professional astronomer, I usually know a bit about it. But if I don't, I just investigate it as if I was a reporter, possibly a reporter who has a background in astronomy. So yeah, I do my homework. I talk, sometimes if it comes from an astrophotographer, I'll email with the astrophotographer to find out what's going on. I'll draw on my knowledge, I'll surf the web and see, I'll look for recent papers on the topic and read up on it. And then once I feel I know what's going on, I'll try to put all that sort of down for a second and try to think, what is this really about? And maybe try to lead with that. And then trying not to, trying to create a story from everything I've read and see if it works. And usually it doesn't work, so I edit it and edit and edit and edit and edit. So I do some, but I don't do them all. So Jerry Bennell does them all. And we have actually a guest writing program for professional astronomers. So on many Wednesdays, we have some guest writers do that. But I end up editing those usually a little bit.
Well, and so Kevin has a question about the Earth rock that's older than the Earth somehow. He asks, is it from the moon Hayden in age then? Maybe.
Well, first of all, I'm not a geologist. It's not older than the Earth.
That was me.
Okay. It's the Earth is older, but we can't find rocks on the surface that date older than that. Or it's close, actually. It's very close to some rocks that are aged on the Earth. It's not older than the Earth. It's possible we could find rocks on the Earth that are older than the Earth. But so far, to the best of my knowledge, that's never happened. In fact, recently there's been, from outside the solar system, there have been two asteroids that came from outside the solar system. If they left off a little debris as they went around. If one of that piece of debris fell to Earth, it could well be older than the Earth itself.
Okay.
If it fell to Earth and survived, right?
Yeah, and survived.
Yeah.
Right.
Yeah. So you're doing some research with meteors with stuff that has fallen to Earth. Aren't you doing some microscopy?
Oh, we haven't done that in a while. So I sometimes I go on strange little binges. So yeah, so what you can do is you can put magnets out and you can go over gutters and things like that, or large pieces of ground with magnets. And many, not all, but some micrometeorites are magnetic and they will stick. And so what you do is then you get a bunch of those and you sift through them and you try to find ones that have unusual structures. And some of them are melted. And so why would you have something that's a tiny little thing that's melted? And so we've taken them to get their elements analyzed and found most probably that they are micrometeorites. But that's actually not a current area of research. Sometimes I just go off and I'm not the only one who have ever done that. They just go off on something that seems interesting. So maybe Alice should pick out the questions. There's too many now.
Yeah, Michael Kuzer wants to know who started the silly pet links to lighten up the APOD presentations.
Okay, someone knows that.
Yeah.
Do you want to answer that?
I do know the answer to it, but you should answer.
Okay, so I guess that's me. So APOD is also not just education, it's entertainment. And it needs comic relief sometimes. So this happens in movies, not so often in textbooks, although it should. So you put in just a silly link. So you see something that describes, and sometimes you think, well, I bet a cat or a dog could show that emotion. So I link some word or two in APOD to a picture of a cute cat or a funny dog doing a funny thing. And it's comic relief, which I consider not just fluff. I think it's actually pretty important. And there are people who go searching for those links. So it's just kind of fun.
Well, I have a related question. Robert, what's your favorite movie? I'm imagining it's a space movie of some kind. And Alice, maybe you can tell me that too.
I guess it's 2001: A Space Odyssey. So that's a space movie. One of the early ones, one of the better ones. It's by Stanley Kubrick, and there's this big monolith found on the moon. And it's this smooth, big, rectangular thing. And we don't know what it is. And there's 3 monoliths in the movie, and it was written by Arthur C. Clarke, the main books. So it's really cool. You can probably rent it for free. It's probably on Netflix for free. That's not a guarantee, that's my guess.
The book is very good too. I really enjoyed. I actually think I liked the book better than the movie, although I've seen the movie a couple of times too. And my favorite movie is whatever cool thing is happening on some planet somewhere that's out there, I think. And then also Dr. Zhivago, but yeah, that's not space.
So I do know Neil deGrasse Tyson. Not well, we're not friends. We see each other at meetings. I think it was earlier this year, maybe it was last year, that I was in his office. And I was trying to interest him in putting together this debate on the 100th anniversary of the Curtis Shapley debate. And so I was up there trying to pitch it to him. And so he was kind of vague, wasn't quite sure. And he ended up not coming in and being part of that. So we sort of ran that without him. But I do joke though with my wife. So when I went into his office, we had seen each other many times. He wanted to do a bear hug. So I'm not really a hugger. So I was kind of hesitant, but he said, come on in for a hug. So now I tell my wife every time she gives me a hug that I don't know, it's pretty good, but not as good as Neil deGrasse Tyson. Got a way to go.
Jim saw Space Odyssey here at Michigan Tech in the late 60s.
Oh, cool.
All right. Well, we've got just a couple minutes left. Anonymous says you should be on Star Talk. I don't know what that is.
That's a show, that's a radio show. I think it's more than radio now that Neil deGrasse Tyson runs. Thank you. I would like to do a little of my research for the last couple of minutes and do a poll for whoever left in the
That'd be great.
audience.
All right, let's hear about your
I'm going to show a slide, and then I think Sue is going to run a poll for people. So I'm going to share screen again. So here's some questions about my research. So this is a complete change of speed, really speed. So you point, okay, good, let's spread. You point your laser pointer slightly away from an infinitely long wall, infinitely long. Slowly, you move your laser pointer around, so the laser pointer points toward the wall. You continue your spin all the way around. Where is the first place that laser light strikes the wall? Is it A, at the point on the wall closest to the laser pointer, B, infinitely far down the wall, or C, at some place between the closest point and infinitely far away?
Oh, this is one of those math questions.
Well, I'll give people a minute to do this. Do we have a hard cutoff at 7?
No, we can keep going. But while people are voting, in case people do need to leave at 7, I'm just going to take this opportunity to thank everyone for attending Husky Bytes and to remind everybody we're going to start back up January 24th. Thank you, Robert. Thank you, Alice. It's been an honor and a pleasure. And we're going to continue hanging out. But Sue, go ahead and stop the recording. Well, no, just keep the recording. I think we'll keep recording. And Robert, you tell us when you're done, okay?
Okay.
All right. So,
okay, so
it's interesting. Usually the alumni have our attendees have a clear favorite.
Well, it's kind of divided here. So the winner was C, at some place between the closest point and infinitely far away, and that is the correct answer. So we have some smart Husky biters out there. It's tough though, it's really tough. So the reason why it's not infinitely far down the wall is because it takes light an infinite amount of time to get infinitely far down the wall. That seems to be the most intuitive. The reason why it's not the closest point is because you can see the spot move. It was over here before it was over there, so it's not at the closest point.
Huh.
Okay, so now let's do one more. There's only one more. I'm going to try to close that poll and go to the next one. Which way does the laser spot move from the last question? Does it move along the wall, getting closer to your laser pointer? Does it move along the wall, getting further from your laser pointer? Or is it something different? So I'll give people a minute or so.
I will tell you, I got the last one wrong in my head. And in this case, I want to say A, but I bet you it'll be wrong. So we have three
It's a
choices.
battle.
It moves, yeah, there's three choices.
There's no real clear favorite here. It's a tough one. So we still have votes coming in.
It's a pretty split tie, 32%, 33%, and 35%. So some people think it moves along the wall, getting closer to the laser pointer. Some people say it moves along the wall, getting further from your laser pointer. And some say it's something different. So Robert, your multiple choice questions must be really hard in class.
Some are not, yes. So should we stop for the voting, or how should we go on this? We got 80.
Yep.
Okay, so the number one choice was C, something different, and that is correct. It is something different. Here's what happens. When you move your laser pointer around, two spots, one spot breaks into two, one moves toward you and one moves away. That's called relativistic image doubling, and it's relatively unknown. And that is one of my major research topics now. I study relativistic image doubling because it occurs all over the place, and we're starting to see it more with modern technology being able to see things faster and faster. And it's able to be seen out in the universe, and it's able to be seen in many different ways. And but people generally don't know about it. Almost nobody knows about it. But I think it's not only possible to see, I think it's useful to learn about our universe. And with the technological frontier moving to faster and faster and better and fainter, we're going to be able to see these all over the place. So very good, Husky Biters.
It's 19 hours.
Very, very impressive. So with that, I'm going to stop sharing my screen again. And I will take questions on anything. I do other topics of research, but that's one of my newer ones that
all right, and I think there's 27 answered questions. So folks, if you click on the Q&A answered, you can see the ones that were answered. So Stephen sent his first email in 1995, and you guys launched this APOD. So you were kind of on the frontier there.
yeah, we're older than Google.
Excellent. We have an alum or a friend of Michigan Tech whose nephew works at JPL and is the lead programmer for the Mars helicopter.
Oh, wow.
And that's Kurt Archer.
Very cool.
And so who funded the Michigan Tech Observatory? James wonders, was it Professor Perfect Circle Callahan?
Yeah, it's named after his parents.
Oh, that's cool.
He passed recently. I didn't really know him. But yeah, he built the Michigan Tech Observatory. And again, a lot of astronomy, it's a good place to go. It's a good place to see stuff, but a lot of cutting edge astronomy is now done with major telescopes, either orbiting the Earth or in Hawaii or in the Canary Islands or in the Atacama Desert in South America. And they put the data online and you bring it offline. You make a proposal to use that telescope. You don't usually even go there, and you're sent back the data. There is stuff you can do with small telescopes, but most of the research at Michigan Tech and at most major universities now involves major telescopes, if not theory.
And the professor's name was Dave
Chimino.
Yeah.
Yeah.
An M.
Yes. And he was famous for drawing a perfect circle on the board. I never saw it though. Someone had a video of it. I'd like to see it.
Are you an artist, Robert? All the art out in your background, are you a painter?
No, sorry. Never really excelled. I'd like to have been. I guess I can still become one, but I can't call myself an artist now.
But you color. I know you color things. that famous
oh yeah. Yeah, I know what you're talking about. Yeah,
I'm gonna go find it so I can post the link.
Chelsea asks, and I'm imagining Chelsea might be, I'm not sure if Chelsea's a student or not, but her question is, are there ways to get involved for those of us that aren't already in the field and involved in research? So Alice is an example of that, right? So Alice was out there working for the Federal Reserve, deep in IT kind of stuff, and she just started following the astronomy picture of the day and then started volunteering to help. And now she's doing this completely for free, even though she's retired.
Yes.
That's not what you're supposed to do when you're retired.
I know. Tell me about it. I keep thinking I'm not doing retirement correctly, but I'm having a blast. But there are different ways to get involved and to do stuff. So one of somebody else who got into doing stuff with APOD a little bit before I did is Judy Schmidt, who is an artist and is a graphic designer, trained as a graphic designer. And she learned how to process Hubble data in Photoshop, because that's a very common package for processing image data. So you can actually download the data from Hubble, Spitzer, all these other places. She actually has a video on how she does this too, out on YouTube. But her images have not only appeared on Astronomy Picture of the Day and National Geographic and around the world on lots of different places. They're so beautiful, but her images have also discovered things. So she downloaded some Hubble data and found a supernova that nobody had found before. Nobody had realized it was there. She processed another image and had questions about it and asked these questions on Twitter. So if you want to follow her, she's SpaceGek on Twitter. So if you look for her images, SpaceGek. So she asked some questions on Twitter, and astronomers, she has a bunch of astronomers following her because her images are fabulous. And a couple of them said, wow, that has not been seen before. So they all got together, and she's the second author on that paper, because it was her image that she's the one who first pointed it out. And somebody else did a lot of the analysis, and there were others on the paper as well, but she's the second author on that paper. So there are ways to get involved in research, depending on where your interests lie. And, I'm like all software all the time, but there are lots of cool things to do. There are lots of citizen science projects too, where you can contribute to Galaxy Zoo and a ton of other things. Backyard, what's the one Mark Kushner runs? So if anybody wants to hit me up with, well, I don't know if this is.
Alice, feel free to put your email out there if you want.
Okay, that's what I was going to offer.
I had a feeling, yeah, no, and
yeah.
What you guys have just spoken about is a topic so incredibly interesting, right? It's the first thing we saw as children laying out on the, past our bedtime. So we have a middle school teacher who teaches middle school science and has a degree in biology and integrated science. She's, he or she has wanted to pursue a minor in physics or astronomy. I figured math would be significant. I know with my degree, I took some math, but I'm not sure nearly at the level I would need. And so I think the question is, so I'm assuming this person already has a degree. So what is something they could do as a credential in astronomy? Do you have any graduate certificates, Robert, that this person might be eligible to take? Or
yeah, there is a new graduate certificate in astrophysics data, astronomy data. So you could enroll and get a degree. You can minor in astrophysics also if you're an undergraduate, but if you can get a graduate certificate, you can just email us and we can just give you stuff to do. You wouldn't get a degree. We could, yeah, the amount of math needed can be high, but it doesn't have to be high. There are many things. Programming is probably more important than math straight off, but being able to code in some language, Python or JavaScript. So
Kevin asks, what are quasars? But before you answer that, there's a comment from Tom that made me giggle. So this David Chimero was once asked how he drew a perfect circle. He deadpanned that he kept the radius constant. And then Warren stated, we tried to ask questions that would require him to draw a circle just for fun. Anyway, what are quasars?
So quasars are big black holes. They're millions to billions of solar masses times the mass of the sun, and they're surrounded by infalling material. So the black hole itself does not emit much radiation, but it creates around it an accretion disk and things falling in. And when things fall in, the gas falls in, it heats up because it keeps colliding with itself. And if it's in an accretion disk, it keeps colliding itself. So quasars are actually very bright, but it's not really the black hole itself that's providing the light. It's the material around it that's heated so high and is so energetic that's creating the light. And quasars also have these amazing jets, sort of like we saw in the microquasar that was shown, SS433, during the presentation.
All right, I think we're running low on questions. We've answered 43. So Ogate posted the Discord group for Astronomy Club, excuse me.
Yes.
And I'm pretty sure Alice already probably, did you paste that in the chat as well?
I did not actually. But I'm about to post something else in the chat
And then
to David Watson's question.
So these images are high res, Robert, right?
Many of them, yeah, some of them are very high res, yeah.
Okay. And so if somebody wanted to download them and print them as a poster or something like that, they could, right?
Many of them would make good big posters. People have again, volunteers have written screensavers and stuff like that. So you don't have to do that yourself. You can just go searching for APOD screensaver Macintosh and find it. There's a Google Chrome attachment. There's not attachment, there's a name for it. And so you can get images that way. I have on my phone, my Android phone, there's the NASA app has the ability to put the background of your Android phone, and I think your iPhone as well, to be the last astronomy picture of the day. So thank NASA for doing that for us.
All right, we've posted that Discord group for the Michigan Tech's Astronomy Club. And so Rudy, you can download pictures for any purpose you want, and you could probably figure out a way to make wallpaper. If you mean wallpaper on a wall, good luck with that. But wallpaper on a screen, I think Robert just explained that. And then I think we're about at the end of the questions. Darwin just pointed out there's an interesting NASA picture video showing a shuttle reentry as viewed from the station for one of the last shuttle's missions to ISS. Has such an image been posted on APOD in the past?
You know, I don't think we have that one. I don't recall that one. So if you can send me a link, we'll certainly consider it. So thank you for that suggestion.
Well, thank you again. It was just so much fun to see. I mean, it was like a visual, you know, I was thinking, I've never seen things so stunningly beautiful, I think, this entire year. So thank you. It was truly an honor to learn about your interests, Robert, and your hobbies and your research. And Alice, what a pleasure to meet you. Thank you for all your volunteer work.
Thank you.
All right. With
My
this,
pleasure.
we're gonna call it a day. So thank you and good night, and see you January 24th. Happy New Year.
Thank you, everybody. Happy Thanksgiving.